All right, here we go with our examples. So we want to find the axis of symmetry, vertex, zeros or roots, x-intercepts, and graph it. All right, so here we go. Let's start by finding the axis of symmetry. So axis of symmetry is first. And so we have, let's label, we also want to label, get in the habit of labeling our A, B, and C coefficients because we're going to be using these quite a bit when it's in this format. So A is what's in front of the leading coefficient, leading term. So x squared happens to be the leading term in this one. And then B is what's in front of the x, and C is the one that doesn't have anything attached to it. Axis of symmetry, again, is x equals negative b over 2a. So we're actually literally going to plug b and a in here. So we have, don't forget the negative sign, negative 6 over 2 times, remember there's an invisible 1 there. So just because there's nothing there, or it appears that there's nothing there, there's always a 1, an invisible 1. All right, so we end up with negative 6 over 2, which is negative 3. Okay, so that's the axis of symmetry. Then let's move to the vertex. So the vertex, again, let me go ahead and rewrite my equation, and this time I'm going to write it with a y. It says f of x up there, but remember we can interchange f of x and y if we need to. In this scenario, they mean the same thing. Okay, so different notation, but same thing basically. All right, so we're going to take what we found for x up in the axis of symmetry and plug it in. So we have negative 3 squared plus 6 times negative 3 plus 8. So we plug it in anywhere there's an x. So we get 9 minus 18 plus 8. So 9 minus 18, that's negative 9, and negative 9 plus 8 is negative 1. So that's the y-coordinate of the vertex. So if we put these two together, the vertex is negative 3, negative 1. So x always comes first, and y always comes second. Okay, so let's go ahead and move on. So the zeros or the roots or the x-intercepts, that's next. Okay, so in the last video we talked about how if it's in this format, it's isolating x squared is not going to be the easiest thing because we have this other x in there. So all right, so zeros or roots, let me refer back to my drawing here. So the zeros or roots here, if we notice, they're crossing the x-axis. When they cross the x-axis, that's when y equals 0. So we're actually going to set this whole equation. If it starts out as y equals all of this, we're going to set this whole equation equal to 0 because that's what roots are. It's when your graph is intersecting the x-axis. That only happens when y equals 0. So here we go. So let's try the diamond. It's quickest way that I know of. So in the top is 1 times 8, which is 8, so or a times c. So this should be a review for all of us. I might do another video for you all about just a little factoring review, but for now, we learned this a long time ago. This should be second nature to all of us. So here and here, we're looking for two numbers that multiply to 8 and add up to 6. Multiply to 8 and add up to 6. Those two numbers are 2 and 4. Then the way that we learned it, we are distributing this x squared evenly to both of these and making little fractions. If we can reduce them, we want to reduce. There's nothing here that can be reduced, so these become our factors. So x, that's a positive 2, so plus 2, and x plus 4 equals 0. And then we set each of these individual ones equal to 0. So that's 0 product property. 4 equals 0. Subtract 2 minus 4 minus 4. So x equals negative 2, and x equals negative 4. Okay, so last piece is to graph it. So here we go. Let's move this up. So we're doing this for all 4 of our problems. Okay, if we know our vertex, let's move that down. The vertex is at negative 3, negative 1, and we have roots at negative 2, negative 4. We probably want to make sure that we draw this more into the upper left quadrant. So let's label our axes. Whoops, you can't see that. So let's put the vertex on there first. So remember the vertex was negative 1, 2, 3, negative 1. Whoops. Okay. And the way that we do this, let's write our equation down here again. So y equals x squared plus 6x plus 8. So the way that we find the next 2 points, you need to, just like in geometry for a line, you need 2 points. A minimum of 2 points make a line. In Algebra 2, in parabolas, you need a minimum of 3 points to make the curve. In this case, we have, the way that we find those, we always look at the A coefficient, okay? From the vertex, we always go left 1 and right 1, and then up or down whatever A is. A also happens to be 1 in this case, but that is a coincidence. Don't always do that and assume that you're always going 1 and 1 up. Okay, it's whatever A is. A is a positive 1, so we go left 1, up 1, right 1, up 1. And those also happen to be our x-intercepts. So those are our points, and we connect them with a curve. All right, so again, vertex -3, -1. That's x equals -2. And this one is x equals -4. You can also go back and kind of double check. If your points that you're supposed to be connecting they don't work, they don't jive together, something definitely went wrong somewhere. So keep an eye out for that. All right, so let's breeze through this next one. All right, so let's go ahead and label. We're doing the same thing that we did in the last one. Let's see how quickly I can go here so I don't keep you all too long. Okay, so let's do the axis of symmetry first. So the axis of symmetry is x equals -b over 2a. So -8 over 2 times 4, which is -8 over 8, which is -1. Okay, make sure you guys can see that. Okay, good. Then we're going to use the axis of symmetry, which is the x-coordinate of the vertex, and use that to find the y-coordinate of the vertex, plus 8x plus 3. So again, we do that by substituting in that everywhere. So 4 times -1 squared plus 8 times -1 plus 3. So that is 4 times 1 minus 8 plus 3. So it's 4 minus 8 is -4, and -4 plus 3, that also happens to be -1. So the vertex overall is -1, -1. So that one's there, and that one's here. Okay. I know I'm going really fast through this, but please feel free to pause so you can write things down. Make sure you're writing questions in the margins so that we can go through anything that you guys need help on tomorrow. We have one more example after this, and in that example we are looking at the other format for parabolas. Okay, so here we go. So remember, we set it equal to 0 to find the roots, and again, let's try our diamond. So 4 times 3 is 12 and 8. So we're looking for two numbers now that multiply to 12 that add up to 8 at the same time. So two numbers that multiply to 12 and add up to 8 at the same time are 6 and 2. So then what we want to do is take this 4x squared, put the 4, and evenly distribute that x to what is on both sides of our factors, and reduce anything that can be reduced. So if I'm looking at this, I can divide both 4 and 2 by 2, and I get 2x and 1. And I can both also divide these by 2, so I get 2x and 3. And once you've completely reduced them, circle your factors, and those become the equations that we use for our factors. Okay, so 2x and a positive 3 and a 2x and a positive 1, and then we set each of these equations equal to 0. Good, make sure you guys can see it. So 2x plus 3 equals 0, and 2x plus 1 equals 0. And if we rearrange, let's do this really briefly. 2x equals -3, x equals -3 halves. Yes, it's a fraction, but that's okay. Fractions, they work just the same as every other type of number. Don't be afraid of fractions. Try not to be afraid of fractions. I know sometimes it's easier said than done, but try. So we have, those are our two x-intercepts. We have -3 over 2 and -1 over 2. Okay, last piece of this one is the graph. Okay, so let me rewrite this here. 4x squared plus 8x plus 3. All right, so our vertex of this, as we found up in the top, was -1, -1. So I'm just going to draw my graph like this and move this up so you all can see it. Okay, so we do vertex first, -1, -1. So that's right here. And okay, so the x-intercepts that we found, actually let's do this a couple ways. The way that we can get our other 2 points is by looking at the a coefficient, and we can do 2 more points by the x-intercepts. So what this means again is because it's a positive 4, we go left 1 and up 1, 2, 3, 4, and right 1 and up 1, 2, 3, 4. If we draw this correctly, we should end up with our x-intercepts in these locations. So -1/2 and -3/2 or -1/2. And you notice that those all line up to make a good parabola, or a really accurate parabola. It looks nice. It's not all over the place. So, all right, let's do one last example. Again, please make sure you're writing questions in the margins. This one is a lot quicker because it's in standard form. Okay, so here we go. Let's go ahead and label our A, our H, and our K here, because those are gonna make this go really quickly. Okay, so the axis of symmetry. If you look back to the notes that we took in the first video when we were first talking about what parabolas were, x equals h. Okay, so you always flip the sign of whatever's in the parentheses. It's just a general rule of thumb to follow. So x equals +1, not -1, +1. Okay, then the vertex. So the vertex is at, let me write this over here so that you guys have it on your page for reference. The vertex is at h, k. So in this particular example, that's +1, -8. So anything in the parentheses flips the sign, and then anything outside of the parentheses does not, stays the same. So that's 2 of them. Okay, zeros, roots, or x-intercepts. So these are actually much easier when they are in this format. Squared minus 8. Okay, so again, we're setting the equation equal to 0 and we're solving it. So I have up here y equals, but I'm going to cover it up because we're setting it equal to 0. So the first thing we want to do is add 8 to both sides. So we have 2 times x minus 1 squared equals 8. Then we divide by 2. This is the whole isolating the square thing. Now some of you might be looking and going, okay, but there's a -1 attached to that x squared. So are we really, how does that work? Okay, it's still that x minus 1 squared is in the parentheses, and so it makes it really easy for us to go through and isolate that x squared term. Okay, you can also see that there's only an x by itself, so think of it that way. You can kind of think back to Algebra 1. So opposite of squaring is square root. Think back to Algebra 1 and the steps that you take to solve an equation for x. So x minus 1 equals ±2. Now the reason for that is because a +2 times +2 is +4. -2 times -2 is also +4. So we're going to add 1 to both sides. So we get x equals 1 ±2. But we have 2 whole numbers here. We actually want to break that plus or minus up. So we get 1 plus 2, which is 3, and we get 1 minus 2, which is -1. Okay, so those are our x-intercepts, or zeros, or roots. So make sure when you get whole numbers like that, you actually break them up. All right, so here we go. Let's graph it. And then I'm going to give you guys some extra credit problems, and you will be good to go. Okay, now check it out. We have a vertex here that is at 1, -8. 1, -8. So we want to make sure that we take that into account when we draw where our origin is going to be. That came out like Zorigin. Origin, not Zorigin. Okay, so here we go. So let's do 1, -1, 2, 3, 4, 5, 6, 7, 8. Okay, now let me go ahead and write our equation again. So it's 2 times x minus 1 squared minus 8. So our A in this case is +2, which means from the vertex we're going left 1 and up 2 and right 1 and up 2 and putting dots because it's a +2 for A. So if it was a -2 for A, you would go down 2 instead. So then here are our other 2 points that we can use. So we can go to +3 and -1, and you can see that they all line up really nicely for us. So that tells you that you did the parabola and all your calculations correctly. All right, so let me just switch over and I'm going to stick these up, and please make sure that you take advantages of this if you want. We have a worksheet instead in class, so you can't do the problems ahead of time, but try these extra credit problems, and I will see you all tomorrow in class.